first shared their stories in caves, connected art, nature, and science, led us toward new horizons. Who thought to capture motion, spark an engine to life, turn television into a playground? Every day, you create the playful, the functional, and the unexpected. You break down walls and take us to astonishing places. Tell stories, leap borders, and create beauty for tomorrow. Because at Unity, we believe the world is a better place with more creators in it, where everyone has a chance to shape the world.
Hi everyone, welcome to our weekly Unity South APAC webinar series. I'm Sarah from the marketing team, and on the call we have Jenny, who's also from marketing, and from our field engineering team, our speaker Hector, Sean, Tech, and Ife. So a big welcome to everyone joining us from all over the region. We have people from India, Pakistan, Singapore, Malaysia, Philippines, Australia, New Zealand. Very happy to have you live with us today. So some quick reminders about the interaction during the webinar. Please put your questions into the Q&A box below, not the chat box. The chat box is reserved for links to materials and resources only. And we do not use the raise hand function during our webinar. The total duration for today's session, including Q&A, will be around 90 minutes. So as always, we do a lucky draw where one lucky registered person who fills in our survey form will walk away with a Unity Sweat Pack. And the survey link is shared at the end of the session. So in case you're joining from a streaming platform today, you can scan this QR code and register to be eligible. If you're joining from Zoom, there's no need to do so as you are already registered. And we are also giving away a Sweat Pack to the best question today, which we will select at the end of the session also. So these are some of our past winners. Huge congratulations to all of you. Once again, the QR code is here and I will leave it up for about 5 more seconds. All right, so we're in the middle of our Building an Arcade Racer series. Today we are doing part 3, adding interactivity. As always, we pre-recorded today's session last night to optimize quality. But our speaker and the entire field engineering team are present right now with us to answer any questions that you may have. So with that, I'll hand it over to you. Take it away.
Hello, welcome everyone. My name is Hector. I am a field engineer at Unity based in Singapore, and I will be guiding you on today's webinar, Building an Arcade Racer. This is the part 3 of a series, and today we will be looking at adding interactivity. For today's session, we will explore Unity's input system, which is meant to replace the legacy input manager that shipped with Unity from the beginning. I will give you an overview of the input system architecture. I will show you in Editor how to install it and set it up. And the second part of today's presentation is related to how to integrate it with the Unity graphic interface, also known as UGUI. I will show you how the game HUD was put together to display steering, throttle, and brake indicators, as well as an avatar camera and a minimap. We will look at how to implement a key rebinding functionality at runtime from a post-menu screen. And lastly, we will look at adding touchscreen controls that are compatible with the input system. Finally, there's going to be time for answering questions live at the end of the presentation. So, why do we have a new input system? A little bit about how it compares with the legacy input manager. When Unity first started, it would only target a few platforms, and the input manager was good enough to handle the needs at that time. As Unity evolved to support multiple different kinds of platforms, there was a need for a modern input system to be created that allowed different control scenarios, and even support controller types that didn't exist before. In the past, there were a lot of differences between platforms, even when using the same gamepad controller. So it used to be the case that the same USB gamepad connected to a PC, you would take that and plug it into a Mac and you get completely different button mappings. So the new system provides some standardization for the same device running on different platforms. Also, the system is extensible, allowing support for new devices by implementing the ability to bind new controls from any human interface device, also known as HIDs. This means that with the new input system, we can read input from all sorts of devices, such as joysticks for flight simulators, or a special type of steering wheel for racing games, or vehicle simulators. Additionally, a highly requested feature was to have the ability for users to rebind controls at runtime. So let's have a look at how to bring the input system into the project and how to configure it. All right, we're going to start by creating a project. So the first thing that we need to do is go to the package manager. You can find it in Windows, package manager. And after this is done loading, we can go to look for packages in the Unity registry. And here we'll see all the different packages and modules that we can install from the Unity registry. So we need to scroll down and look for the input system right here. So once I have that selected, I'm going to find the install button right here and click install. So you can see how it's being imported into the project. And then look at this warning just now. Because this project is using the new input system, it's asking if we want to use it, we need to restart the editor to gain support. So we're going to press yes and let it work. And here we are. Once Unity restarts, we are ready to use the input system. So now we can confirm by looking at the packages installed in this project that the input system is ready to use. In this case, I have installed version 1.3.0, and for Unity, I'm using 23.29. Okay, I'm going to close the package manager, and let's explore the following. Now that we have the input system installed and Unity restarted, it's ready to be used. In order to confirm that the input system is selected, we need to make sure that that's the case by going to the project settings that you can find in the edit menu item, project settings. And once this opens, look for the player option here. And on the right side, scroll until you find the option that says active input handling. And make sure that we have the input system package selected, which is the new that we just installed. Input manager is the old system. Interesting is that you can have both active and they're not exclusive of each other. So be careful. It's possible to have both running at the same time as long as they're not like interfering with each other. But it's not recommended, not really, if you want to make use of all the new features of the input system. So in my case, I'm going to just select the new one and exit and close the project settings. And that is installing the input system. These are the main concepts of the input system. We have devices, controls, and actions. So devices are any peripheral that you can connect to your computer or console, and range from gamepads, keyboards, mice, to joysticks, steering wheels, etc. Also, devices can represent abstract sensors, such as gyroscope or accelerometer. Let's take, for example, the DualShock controller. there is a device definition built into Unity input system for this particular controller. So this is seen in Unity as a device. Controls are generally tied to everything on the device the user can interact with, such as the left and right sticks, the shoulder buttons, the triggers, as well as any of the other face buttons. And finally, actions. These are related to the specific abilities that you want to allow your players to have in your game. For example, in the context of a driving game, we would have actions such as steering, accelerate, and brake. In the case of a third-person perspective game, the actions could be the ability for a player to decide in which direction to go, when to jump, or interact with elements in the environment, such as picking up collectibles or opening a door, for example. Actions also allows us to interact with the UI. In case of a menu screen, we can define the ability to move up, down, left, right in the menu's items. And we can also define actions to confirm a selected button, and another one to cancel or back out of a menu screen. Generally speaking, in PC games, building UI with buttons that respond to mouse clicks is a typical approach of many developers. But it's a good practice to also test and support non-pointer navigation, such as keyboard or gamepad to navigate the menus. You can still support mouse and touch. However, allowing the users to control the game with a gamepad is a best practice and a requirement if you are interested in making games that can be certified as fully gamepad compatible. And this is also true when you are targeting consoles such as Xbox, PlayStation, or Nintendo Switch that don't rely on pointer devices. Because we can have multiple types of actions, we need a way to group them. These groups are called action maps. So you can simultaneously enable or disable all actions in an action map. So it is useful to group actions in action maps by their context. For example, driving, walking, and navigating menus. So these are the action map names that we would give to all the actions that we've seen in the steps before. So here's an example. You can see in this table that I have a column for devices with a gamepad and a keyboard, as well as controls. The controls could be, for example, the right trigger and the left stick for the gamepad. And for the keyboard, it could be the arrow keys or control. And then we can have two different action maps. For example, a group of actions called driving, which has all actions related to driving a car, like steering, acceleration, boost, for example, or navigating UI, such as actions such as movement, confirm, and cancel. So if I were to hook this up for a gamepad, I would choose that for the gamepad, I'm going to use the left stick in the driving context to steer the car. But I also want the left stick when the game is paused to be able to allow me to navigate the UI and movement. So it's the same left stick connected or bound to two different actions. The key thing here is that we will only have one action map active at any given point in time. And this allows us to route the input into the different behaviors. But this is also true for multiple devices. So I could have the gamepad left stick used for driving and steering, as well as navigating the UI and define the movement. But I can also do that thing with the keyboard. So I could have the arrow keys used for driving and steering, and the arrow keys could be used in the navigation context to define the movement. And this could all be running at the same time, or these bindings can be defined at the same time, but they will be active depending on what is the input device that the user is interacting with at the moment, whether it's using the keyboard or holding on a controller. Let's have a look at how to create input actions in the editor and set them up for use in cases such as the ones described just now. Okay, now we're going to set up our input actions. In order to do so, we need to go to the project window, right-click on it, and select Create. Then if you scroll to the very bottom of the list, you will find the option that reads Input Actions. When I click on that, a new file is created, and the default name says New Controls. Let's call it something like for example, player controls. Give it a name. Then if you look closely, this is a file created. It's like an asset, but the extension is not asset. The extension is input actions. And this will have all the definition of our devices and the input actions and the actions that the action maps and the actions that we want to bind together with our devices. By the way, this is stored as a JSON format. If we double click on this, we will see this new window, which is the input actions window, to examine what is the content of that player controls file that we created, the input actions definition. So here we have a column for action maps and another one for actions. So we can create the same way that we discussed earlier, how we can have a game with different activities. For example, to drive a car or navigate the menus, we can do the same thing in this window. So let's create first the action maps related to all these activities. Click on the plus button, and then a new action map is created. Let's call this one driving, for example. And then on the right side, you can see that a new action by default is created and added. So we can rename this by double clicking on it. And let's call this one steer. Then we can add another action for the driving in the driving actions map. And this one could be called accelerate. And finally, one more called brake. So now we have my actions defined in the driving action map. We can create another action map such as walking. There we go. And the actions for walking could be direction. It will be the walking direction. Another button could be to jump, the action of jump. Another one could be interact. In case we interact with an item like a collectible, pick them up, or maybe there's a door, we can interact with the door and open the door. And finally, we can have something like in the menus, or you can call this UI. And the actions could be, again, movement, select, and cancel. So this is an example of creating the actions and assigning them to the action maps that we were working on just now. By the way, these actions are very easy to drag and drop into different groups. If I move the brake into UI, that's wrong. I can drag and drop it back into driving, for example. And it's also easy to copy paste this. This is very helpful. Okay, next step is binding. We're going to bind the device's controls with actual actions that we created just now. So in order to do so, I'm going to give you an example. So you see driving action map, we have the steer, accelerate, and brake that we created earlier. If we select and expand, you see there's no bindings associated with this. And on the third column here, now you see the properties for this particular action. So by default, all actions have a type button, which is helpful if we want to have like one-off things that happen and we want to perform when at the press of the button on the keyboard or on a gamepad. In the case of steering, we want to associate this with the movement left and right. So we're going to associate this with the keys on the keyboard, the arrow keys left and right. But how do we do that? We need to add a binding for that. In order to support the two keys left and right, I need to create what is called a composite. So in order to do so, I can click on the button Add Binding, and you can see there's these options. I can add more bindings. I can add one or more bindings. So meaning that I can imagine that is an action that I can trigger by pressing different keys. So I can press the key A and the key B, and they will all be bound to the same action. So regardless of which key I press, the action will trigger. So in this case, I don't want to do that. I want to add a composite. So I'm going to add this one called Add Positive and Negative. And when I do that, you see what it's called. It's called One Dimension Axis. And inside there is another binding, one for negative and one for positive. This means that I can define for the negative what is going to be the button press that I need. In my case, it's going to be the left arrow key. And for the positive, it's going to be the right arrow key on the keyboard. So to support this, I'm going to go to by having negative selected on the right side where it says binding, there's a path. And this dropdown, when I open it, this is very interesting. Here I have so many different options that I can use. And so many different devices. In my case, I'm looking for the keyboard. And then I can look for it in the list of all the keys that are usually on the keyboard until I found the one that I need. For example, arrow should be somewhere here. Here. This is negative, so it's going to be left arrow. And then that's bound to the negative. And for positive, I'm going to select right. So there's another way of finding the keys that we want. We don't have to search for it and find it in the list, even though I know it's here. But imagine I'm at the very beginning, I'm not sure where it is. So there's this button right here that says listen. When I click on that, I can go to my keyboard and press the right key. And when I do that, you see that it shows up. And the right arrow, and the one key I press just now, as well as any key. Any key is also another option. Imagine there's a window that says press any key to continue, and then the action of continuing can be bound to any key on the keyboard. And pressing any key will trigger that action to continue through. But in this case, I'm binding the positive one-dimensional axis. So I'm going to select the opposite of left arrow, which is right arrow. And now I have left and right associated with this. This one is empty. I think I can safely delete it. And then this means that whenever I press left or right, this is going to take a value between -1 or 1. And if I press none of them, it's going to be 0, the one in the middle. And this is exactly what I need. So that steer, whenever I test this value, this should be a value set to type axis, I can read a value from -1 to 1, meaning that if there's no key being pressed at any point, steer, by testing the steer value will always be 0. If the left key is pressed and testing the steer value will be -1, and if the right key is pressed, the value will be positive. And this allows me to have the steering binding done correctly. For accelerate, I think it's similar. We can select this. We can define a path for accelerate. In this case, it's going to be, I'm going to click listen, press up arrow. And for brake, I just going to select the following. Click on listen, press down and down arrow. So you can see how I created a one-dimensional axis for steering left and right. But for accelerate, these are actually, in a real car, there's two different pedals. So you're going to have two different separate actions. It's not like one pedal that you push forward and you go and you pull it back and then you brake. You can actually press both at the same time. So that's why I can create different bindings for each one of these separate options. I just need to make sure that these are not action type button, because then that will just trigger an event once. Instead, it should be a value. And the value can be considered an axis. Next up, make sure the brake also has the same type of action type set as value, and control type is also axis. And that's how we bind the keyboard to the actions. So my left and right arrow keys will drive the steer action, which is a one-dimensional value from -1 to 1. Well, the up arrow will drive the accelerate action, and the down arrow drives the brake action. Okay, now let's go and see walking, where I can set another type of composite. So in the direction action, there's no binding. I can select this to be, first, I need to define that the direction type will be a value, and the type of value is going to be the vector 2. So let's delete this. You see, but by having set the direction control type to be a vector2, when I add a binding, it will offer me one of these, up, down, left, right composite. When I select one of these, it automatically creates a representation of a 2D vector and all the components. It's very similar to the one-dimensional thing that we created earlier, only that instead of having one axis, we have two axes. And we have to define two different buttons that define the negative and positive values for each one of the axes. For example, as we did before, up is going to be, I'm going to click on listen and press on the up arrow key and select that. Down is going to be down key, select that. Left, listen, press on the left and select it from the options. And right, the path is going to be, I click on listen, press the right key on the keyboard and select it from the list. And now I bound my keyboard arrow keys to this 2D vector composite that will drive the direction value, which is a vector2 type. And then for jump, I can, this one in particular, I'm going to leave it as a button. I think it's a good idea because it's a very specific action, like an event that happens. So I could just like bind it. Let's maybe press on the spacebar. And for interact, usually the keys in games are E. Oh, you will remember from PC games that first-person controllers usually use the WASD keys to control direction. So we can support both the arrows and the WASD. In order to do so, you just need to go to direction and add a new binding. Another up, down, left, right composite is an option. And basically we bind it with the keys that we just defined just now. So, and also because we have two of the same type, maybe it's a good opportunity to give them a name. For example, I can call this keyboard or arrows. And this one right here, I'm going to call it WASD. And then for the up, I'm going to bind it to W, select. For down, I'm going to bind it to S, select it. And left, I'm going to bind it to A. And right, I'm going to bind it to the D key. And what this means is that no matter whether I use WASD or the arrow keys on the keyboard, whichever keys I press, there is this thing that is called the process of disambiguation between these two bindings, and the binding which generates a value of greater magnitude will take over and drive the action. In this case, the direction action. So the vector2 will be defined based on WASD or the arrow keys, whichever is pressed. And this way I can just keep adding support to control my character with different keys on the keyboard, but the code will be bound to the direction value. Same thing, I can add more keys to alternative keys to make the jump button on the keyboard. And same thing for interact. So now what if we want to bind the controls to a game controller, for example, the DualShock? So in order to support this, we can use the input system and add a new binding type. Let's have a look. So the same way that we did before for direction, and we define arrows and WASD, these are composite binds that are used in the keyboard. So we can add a new binding here. It's going to go at the end of the list. And here I can select the options from the drop-down menu, Gamepad. And Gamepad, you can see that there is a PlayStation controller option right here. So I can select that and look for DualSense, that's the PlayStation 5, or DualShock 4 for the PlayStation 4. And then select the D-pad, left stick or right stick. I'm going to select the left stick. And now that's bound to the left stick on the DualShock controller. So this is very helpful, but it's also very specific. What if I have another type of controller with me? I have an Xbox controller. Then I need to add another binding for the Xbox controller. So this is a bit troublesome, and there is a solution for this. So instead of binding it to a very specific control, what the input system allows you to do is smart enough to define like a base class for these controllers. They all fall under the gamepad category, and gamepads are similar in features and layout and buttons. So they both have left and right stick. So what we can do is look for the gamepad option, left stick, which is going to be bound to the PlayStation 4 left stick or the Xbox One controller left stick, regardless of which one it is. Or anything that is seen as a gamepad, including like a generic USB gamepad, will also be picked up and bound to the left stick. So this is a recommended version if you want to just do one simple bound stick to your action. And this will work regardless of you using the gamepad or if using the keyboard. You can use WASD, the arrow keys, or the left stick on your gamepad connected to your game. Next, for the jump, we can do the same thing. We can add a new binding. So I press plus, add a new binding. And for this, I'm going to bind it to gamepad. And I'm going to look for example, I want to bind it to the X key. So how do I do that? So again, I look for PlayStation controller. DualShock 4. And this is the cross button that I want to support. So I'm going to click on cross. Again, we have the same problem that this is very specific for the PlayStation controller. So if I want to use the Xbox One, instead is the A button. Again, I could bind both and hope that the users only use PlayStation or Xbox controllers. But if they have a different type of gamepad that is not specifically one of these, the best option is to rely on the gamepad type. So I'm going to undo this and look for gamepad. And what gamepad has is these options right here. You see it says button east, south, north, and west. So it's following the main directions. And let me show you what I mean by this. So north, south, east, west will be the same, will follow the layout for different types of controllers. So if I say south, I bind it to the south button. It's going to be A on the Xbox One, and it's going to be X on the PlayStation. And if you want to be specific, like in Nintendo Switch, the south button is a B. It's not an A, so it could be more confusing. That's why it's very helpful to use this layout approach, where you can define the button south on the gamepad to be the button you want to bind to this action. And that's how you can support it. Same for interact. We can add another binding. Let's see, this one could be button west. And that's how we support gamepad binding on the different types of interactions. So now, if I use the gamepad, I can drive the direction action using the arrows on the keyboard, two different types, WASD, the arrows, or using the left stick. The jump button, I can use a space bar on the keyboard, or I can press a button on gamepad, and those will drive the jump action. And the same for interact. So we have E for the keyboard or button west for the gamepad. And that is how you can do binding of gamepads as well as keyboard in the same actions. Okay, let's take a moment to see if there's any questions so far.
We're pausing for a quick Q&A break now. So quick reminder, we are giving away one swag pack to the best question. Hector, I'm handing it over to you if there are any questions you'd like to take live.
Yes, I'm looking at one in the questions box right now. It says, how did you add options to players with disabilities so you can customize bindings and the controls? Yeah, this is a very interesting subject. Actually, I'm interested in accessibility, and I've been investigating on different platforms such as the web and how that works. I know in Unity we have teams also that are passionate about accessibility, and even we're considering adding those functionalities to the Unity editor itself. What I can say for you right now is something that I touch on later on in the that I explained earlier, which is that for making games that support gamepad and mouse, it's a good practice to support the keyboard and navigation using exclusively controllers. Think of the games that are certified as gamepad compatible. Those usually serve the purpose of becoming more accessible. So by properly binding your UI to use the input system and testing and making sure that it works with one type of devices, and it doesn't require, for example, you can play with the gamepad, but when you're in the menus, you have to use the mouse. That is not accessible and will not pass certification if you're trying to target a game for consoles. So that is how you can think about adding accessibility to your applications. That's a very good question. I think we're going to move on. There is another Q&A checkpoint later on, and we're going to take more questions at the end. Okay, moving on. Let's continue with the presentation. Another very helpful feature of the input system is the input debugger. Let's have a look. The input debugger can be found in the Analysis, Input Debugger. By clicking on this option, it will open a new window that shows all the devices that are currently connected to and seen by Unity. In this case, oops, right here. In this case, you can see keyboard and mouse are connected. The keyboard. So if I press keys on the keyboard, you can see how that works. I have a view to show you the keyboard right here. So if I press on the keyboard, you can see what happens. Let me show you again the mouse. So when I move the mouse, it's generating position information, mouse delta. So that is reported and seen here. And lastly, say that I want to plug in my controller. So let's try and do that right now. So I can connect it. I think this one can be connected by Bluetooth as well, but I have it connected via USB cable in my case. I'm just going to connect it. And now you can see that DualShock 4 gamepad appears as the device. Same thing that it did for the keyboard and mouse. I can double click on it and you can see that the values are reported. The triggers, the face buttons are, you can see me using the directional controls, the sticks, right stick, left stick, the triggers. I can squeeze it halfway, you see 0.5 until 1. And this is how you can monitor and make sure that the values that you want to read from your device are accurate. So this is the input debugger. Very useful feature. Also, there is this thing that you might have noticed called interactions and processors. So I'm going to show you what these are later on. But basically, interactions is a way of designing when the action will be triggered by adding some rules that you can see here. These are some of the ones that come in, like for example, holding a button for a while, pressing it multiple times, or in the case of you can support like a double click or a triple click. Press, slow tap, meaning like press and hold for a while, and tap. And processors are ways to modify the values reported by the device control. For example, very common use of axis dead zone is for game gamepad sticks, where when the user is not touching them, they should go back to the center by default. But if for any reason they're like off the center, they might report like a non-zero value. So we can make it so that there's a dead zone, meaning that if there's a minimum, if the value is smaller than 0.1, for example, you can clamp it or make it go to 0. Normalize scale to multiply and change the direction, for example. A very good example of this would be do the vertical invert the vertical axis in some games where some people prefer when pushing up on the gamepad the camera will look up, but some people prefer when pushing up on the gamepad the camera will look down, like a flight simulator. And these are interactions and processors. I will show you some of these, how they are implemented in the arcade racer in a short while. One important thing to keep in mind with the input assets window, whenever you are editing it here, you will see that there is you have to save the asset. So until you click save, the asset is not automatically saved. There is an autosave box here, but you will be reminded if you make changes and you close it that you need to save it. And those settings and bindings are all stored here. Also, you can see that if you expand on the new arrow that shows up there, you can see the controls that we created under the input maps settings. For example, driving accelerate or walking direction. So there is also this very helpful documentation migrating from the AltInput system, because now that we created the input assets, how do we listen to this? How do we test these values in code, right? So in the past, we would do something like input, get keyboard, get key down, and then pass a key value, or gamepad. We test an axis, and then we need to define the gamepad through the input manager, which was complicated. So the closest thing that the new input system allows you to do is something like this. We can expose in code an input action type, and that will show like this in the inspector, where it's like a mini input asset definition where we can do a binding on the inspector directly. And we can bind it to a mouse, left button, and the left control key as well. And that will be bound to a fire action. And in code, we can subscribe to perform event. And the handler will be this function that receives a context parameter, doesn't do anything with it, doesn't have to do anything, and it will just invoke the fire method. Or you can do it the way I showed you just now, using the input actions by defining them. To be able to get access to these things using code directly, one option to go about doing this is by generating a C# class out of these input assets. This checkbox right here, when you select the asset in the editor and you go to the inspector, let me see if I can bring that up real quick. For controls, this one in particular is using it. You see, generate C# class. So it will show you the class file where it will be generated, and from there on it can be used to test the values. And this is how you would use it. So in this example of input assets defined in such way, such as gameplay fire, the way to use it would be in a mono behavior. We have a reference to the generated C# class. Then we create an instance, we instantiate it, and then we get a reference to gameplay and fire. And the perform is going to be the event, similar to what we did before. And we can subscribe and call the fire method when appropriate. You can also test using shortcuts for the common type of devices such as keyboard, gamepad, mouse. So for example, by doing keyboard current, there's also shortcuts for all the different most common use keys. Was press this frame and do something about it. This could be inside an update function. And you can resolve the space key by using these indirections, or you can use the keyboard current and pass a key. Or you can also pass the key name as well. All of these result in the same value, reporting whether that key was pressed this frame. This is similar to the AltInput system GetKey app. There is a was released this frame shortcut. So if you are familiar with the AltInput system, you can go through this guide and have a good idea of how to use it. However, I would recommend still to pay more attention to the input assets and how to subscribe to those actions. So another way to test input is through the PlayerInput component. So here we have our car, and on the inspector on the right side, I can see all the components attached to it. You can see that one of them is called PlayerInput right here. So PlayerInput, I need to define the actions, which is the asset that we use just now. And then we can also define a default map. We have two input maps. Sorry, we have two action maps, and I'm going to define the car to be the default one. These two you can disregard for now. And then the interesting thing right here is this one, behavior. There is a drop-down which allows me to select what is the behavior for communicating the input back to the code. There's different techniques. So send message and broadcast messages is using the Unity's internal broadcasting system that communicates to mono behavior. So and you can see in the inspector right here that is showing you that if we use send messages, all the actions that we have defined in our input actions asset are listed here, and it will have created a callback for each one of them. For example, on accelerate, on brake, on steer, meaning that if I declare those methods in mono behaviors that are attached to this game component, those will get called by this player input, because we have this behavior set to send messages. Similarly, we have broadcast messages, which behaves similarly to the send messages, but also will notify children nested inside this object. Unity events. This is actually recommended because even though it runs in the managed side, it has very little overhead, and you can see some events that you can subscribe to. And we have done that actually for this particular case to show you how this works. Accelerate, callback, I can define a target game object, and then through reflection, I can see all the components attached to this game object, and I can choose which method I want to call. So I have this function, I have this mono behavior called car input handler that I created alongside player input to receive the events from player input. So you can see how from car input handler, the top methods are handle accelerate, which is something I created for this purpose. So if I open car input handler, this is what it looks like. Handle accelerate is going to be a method that takes an input action callback context type parameter. And I receive this parameter and I'm able to test the face. So the most simple way of doing this on accelerate, for example, would be to use the send messages behavior. By doing that, and as the inspector details here, is going to call all these methods. For example, on accelerate when that happens. And on accelerate, I have it right here, is helpful. Every time there is that action is triggered, this is going to be called. However, what I noticed by using this is that there is not a lot of information because there's no context. So if you need to have context, for example, when the key was pressed or released, in those both cases, on accelerate, using send messages will be called, and there's no way to tell them apart. So in this particular case, it would be okay for buttons, but this is a float value. So whenever the action binding is actuated, it will report on accelerate, and when it's released or cancelled, it is also going to report. So in the cases of accelerate, maybe it doesn't make sense to use send messages, and we could use instead the approach of Unity event as we created just now. So handle accelerate is going to be called on this function. Handle accelerate takes the context, and then I can test the face. And let me see if I can test it real quick. I should be able to disable the car from driving. Let me see if this works. I need to get myself out of the way though. And press the accelerate key. Yes. So you can see in the console right here that if I using the keyboard, so if I press W, it's going to save performed, and when I release it, it says cancelled. So the context has this information about the phase of the action being triggered. So this is helpful in this situation. The other thing that this car input handler is doing is getting a reference to the player input. And why is it doing so? The reason is so that it can access the actions through this API. We have the ability to call find actions on the player input actions and pass a name. So this is the name of the action that I created in the input actions asset, and read a value. So what I'm doing here is actually I'm doing dependency injection on the car controller through a delegate that will return a float, and I'm binding that to my read value method on the accelerate function, meaning that every time from the car controller I want to test the acceleration value, I'm going to invoke this read value float on the action accelerate, and so on the next for the brake and steer as well. I'm back in the car controller. I can show you where is the place where I define my delegate. I have a delegate that returns a float called float provider. And then I declare 3 providers for steering, accelerate, and brake. And what I created was 3 properties called input, the prefix input, and then the identifier for the type of action, input, steer, accelerate, and brake. So that if these float providers are defined, they will be used. Otherwise, the get default value will be called, which is just a normal method that returns a 0 float. So by doing this, I can use these property getters throughout the code to test the input, steer, and acceleration and braking. And because I have the car input handler on the awake function, I define the externally, I inject the dependency of this class to feed in the values of the actions. That's how I can get the car controller to be able to read the values from the input. Another thing I wanted to show you is the action interactions. The interactions can be found here in the input actions window alongside in the properties for the action. For example, I have my car action map. I have a toggle pause action. This action has an interaction pane here on the right side. You can see that it has a press interaction set to it. There's a note here that says that if the action type is button, this is redundant, is unnecessary. But it's basically, in this particular case, is going to be pressed and held for going over this press point of 0.5, which is a default, by the way. But it doesn't have to be this. We can change and select other interactions from the menu here. So I want to show you that this toggle pause action is set in the car action maps. It's bound to the P key on the keyboard and the start button on the gamepad. And actually in the action map for menus, we have another toggle pause. This toggle pause is also bound to the same keys. I actually created it once and did the bindings once and then copy and paste it over to the menus. So they are exactly the same, but they don't have to be. So for example, I want to make it so that when I press the toggle pause, none not when I press it immediately, but when I press and hold for a few seconds, the pause menu will pop up. How would I do that? I can add an interaction to this button. So I just need to make sure that I remove this and add a hold functionality, and then I can define the hold time is going to be, for example, 3 seconds. So remember that these input actions, I need to save the asset in order to use it. And also because this particular input action asset is made to generate a C# class, is going to take a second to recompile the scripts. So let's press save, let it recompile. And we should be able to test it right now. However, I need to make sure one thing that I was missing just now. Alongside the player input, remember I had my behavior to send messages, invoke Unity events. I need to make sure that the event is properly linked. So I have car. This is the accelerate I was testing. And there's a toggle pause that is empty. Yeah, I think this was a miss on my part. I need to define it. So I'm going to define it with the same game object. And I'm going to find the car input handler. And it's going to be linked to handle toggle pause. Therefore, when the player input, which is somewhere here, let me minimize this. When the player input action for toggle pause triggers after the holding of the bound controls for at least 3 seconds, then it's going to call the handler in car input handler script. So let's give it a try. So I can drive, and now if I press and hold the P key, well, let me bring this screen. So if I press on it now, it doesn't work. But if I press and hold it for a second, 1, 2, 3, I should see the pause menu show up. And there you go. And this should also work with the gamepad. But because I have a second toggle pause action defined in the menus input actions, they don't use the same interaction. So the interaction to enter the pause state is so that I hold the button for 3 seconds. 1, 2, 3, and it should appear. And there you go. So that is a use for interactions. And that is setting up input actions. This is the second checkpoint. Let's see if we have any more questions. Okay, everyone, I'm looking at the questions box right now. Okay, there's one question coming in. How do you pause the actions in-game but not the UI? That's an excellent question, and just stay tuned and keep watching the rest of the presentation where we're going to cover exactly that. So I think we can move on to the rest of the presentation. Okay, let's continue with the presentation. In video gaming, the HUD or heads-up display is a method by which information is visually relayed to the player as part of the game user's interface. The HUD is frequently used to simultaneously display information such as steering angle, acceleration, and braking. In our case, we also include the car speed as well as a minimap. Let's have a look at how this has been set up. The game HUD right here is composed of these elements that you see here on screen. Let me get myself out of the way. So we are talking about this cockpit camera where you see the driver inside reacting to driving around, like braking and accelerating. We also have the speed indicator on the top left-hand corner, and we have a minimap on the top right-hand corner. And on the lower right-hand corner, we have the steering indicator that could be smooth if we use the gamepad. So if I gently move it left and right, you can see how it reacts. And similarly with the triggers for throttle, I can like drive and steer very lightly. Same thing with the brake, I can apply it lightly and throttle. I can have brakes and throttle at the same time, which is probably not a good idea on a real car. But this is what the game had is responding to, showing the different states of the input actions. So let's have a look at how these are connected and hooked up. So let's exit play mode. And let's look at the UI. So the UI is right here in this game object called PF car UI. So I can double click to select it, go into 2D mode, and we can see this is the minimap, for example. The minimap is simply the way this is set up. We have a camera aligned with the car, pointing straight down, very high up. So it's taking a picture of the car driving, as well as the environment around it. And then it's simply applying the render texture is being drawn by a raw image component. And we have a mask on the parent of this game object. So if I disable it, you see that the mask doesn't apply anymore, and you see the original square rendered texture. The original render texture. By turning on the mask, we can see that also we have a border. It's an image on top of this. I can move around. Then that's revealing actually that the mask is a low resolution image. It's actually using this knob image that comes with Unity. But by adding this higher resolution border on top makes it look nicer. Because masks in the UI system are 1 bit. So that's why we see like that. We can do the nice gradient. But this is a good way to achieve some like nice looking results. And that's also being applied on the cockpit camera. And finally, let's have a look at the indicators, throttle and brake indicators. This is all hooked up directly from the car controller. It's not ideal, but it's fine. We can go back to the car controller, which is in the ANZSEA object. This script called raycast script. It's got reference to the UI elements. The UI throttle is an image. The UI brake is another image. This green and red right here. The steering also is a rect transform that holds this image of the steering wheel. And the speedometer is a text component, text mesh pro right here, rendering at the speed the car is going. So again, if I open this real quick, we can find references to those input, to those pieces of UI. Here we go. So it's a reference to UI throttle, brake, steering. This is how it's hooked up. So in the update function, if UI throttle is defined, it's going to set a fill amount, which is a ratio from 0 to 1, based on the input accelerate, which is the private property is connected via dependency injection from car input controller to basically reach the input of the accelerate action, which again is going to be a value from 0 to 1. That's why when I squeeze the trigger halfway, the fill amount on the UI on this sprite also reacts to it. The same thing happens with the brake. And this is how the image of the steering wheel is rotated as the steer values go from -1 to 1. So you see that the extent of the turn is 135 degrees. And finally, the text in the speedometer is going to be set here. And that's how the values from the input system are passed on to the UI to be shown on screen. and that is Game HUD. One of the most requested features for Unity regarding input is the ability for users to remap predefined controller, buttons, or keys to user-defined selections at runtime. Well, if you are interested in supporting this feature in your next game, I will show you an example of how you can do this yourself in-game at runtime. Let's go to the editor. Next up, we're going to go into rebinding functionality. And for that, I'm going to pause the game. So I have the ability to pause the game. I have that on the P key, and we have the pause menu pop up. Also on this is start function, a start button on the gamepad also brings up the pause menu. And the reason I want to show you this is so that you can see how we can change the input maps. Disable one input map for driving, and then we go into another context where we have another activity that we want the users to be engaged in, which is navigating the menus. We went through this earlier during the slides. So when I go into the pause menu, the first of all, the car stops driving. We basically implement the pause. You see the car is not moving anymore. And then we can use the D-pad or the analog, as well as the keyboard keys up and down, or WASD should work as well. And that is correct. Yeah, it works. Now that we are in the menu, I want to show you the rewinding functionality. Well, this UI is a Unity UI that I can interact with the mouse. Click on it. I can select by clicking on this, and you see that the content on the right is changing as well. But with one of them selected, which is the default behavior, I can also navigate with the gamepad. And then confirm with the A button or the gamepad south, as we discussed earlier. Because it's not just the A button here, I can also use the DualShock controller and press up and down and go through different options. And here's the interesting thing, the rebind controls. So in this option, if I press now right, I should go into the right column where I can navigate through all these different options right here. So this one is showing me the bindings for the keyboard, but it also works for the gamepads. For example, right now the steer is not a good example because it's a composite, remember? So it's showing me just the first side. Let's not look at that one. Accelerate. Accelerate is using W. So this is a good example. It's one key. So I can change this W to be instead the Y key. So I could press enter, and you see that it says listening for input. So at that point, I can press the Y key, and now it shows that it's bound to the Y key. So if I press P to exit out of the pause menu and try to drive with W, it's not gonna drive anymore. Instead, I need to use the Y key to drive forward, because now the throttle action, the accelerate function, is bound to this key. And again, if I press P for pause, go to rebind controls, and press the reset button on the accelerate, it's going to go back to W, which is what it was before. And pause, and now I can keep driving with W key. This is true as well for the gamepads. So I can pause this, go into rebind, and for example, even though it's not showing me the controls for the gamepad, and that's something I still need to work on. It should ideally, if I pause using the gamepad, it should show me the icons for the gamepad. So I want to rebind the brake. Right now it's on this trigger. Let's try to rebind it to the shoulder button. So I press on the shoulder button, and it says left shoulder. Okay, maybe we can do the same thing for the accelerate. Right shoulder. So now I press start to unpause, and now if I press the triggers don't drive the car anymore. But if I press on the shoulder buttons are driving the car. I'm braking. Similarly, I can go to rebind controls and press reset and undo, and now the triggers are working again. I should be able to show you the code where that is happening. Whenever I pause and you see the rebind controls, each one of these rows is represented by each one of these game objects right here, the rebind action. So there is a script associated to it, UI rebind action behavior. So if I open this script, we can go to the API call that allows the rebinding to happen at runtime. And this is what it looks like. It says, perform interactive rebinding. And also note the following methods that you can call. This is to filter out some of the input, because what happens at that time when you start the interactive rebinding process, it will listen to any device connected input. Whatever device controls is actuated will take over and will be bound to the operation. Will be bound to the control that we are dealing with right now. So in order to prevent other things, for example, the P key, that's very important. We don't want to rebind the accelerate action to the P key, because the P key is a reserved key used to toggle the pause menu on and off. And similarly in the gamepad, we don't want the start button to be used to accelerate, because again, that's reserved button functionality to toggle on and off the pause menu. Similarly, we don't want to use escape and so on. So we can add some filters when we are listening for the new button to be pressed. So be mindful of this. And then there is a subscription to onComplete, which calls the function rebind completed. And that is runtime rebinding. Building for mobile or tablets that rely mainly on touch input, we have the ability to add virtual gamepad on screen as an option to allow players to simulate using a gamepad on a touch screen. Let's have a look at how to set this up in Unity. So let's see how to create on-screen controls. So in my hierarchy, which is this one right here, I have this game object on-screen controls that I created earlier. I'm going to turn it on. And what I did here is I added some prefabs that come from the samples. So let me show you where I got them from. So from the package manager, the input system has these samples right here. And there's one called on-screen controls. So I already have it imported, but you can import it yourself. And once you do that, you will find there's these prefabs that come with it. They are here. Once you import the samples, you will find them in Assets, Samples, Input System, and these are stick and button. So these are virtual on-screen base stick, the one you see here for the left stick, and button. So I have two instances of the button right here, A and B, that I put on the screen. Actually, originally they had no graphics. It was like the default UI white texture. But because I had imported some other icons, I managed to select one nice looking sprite for my buttons. But you can put anything you want here. Actually, maybe that makes more sense. Right trigger for this button, which is associated with the right trigger on the gamepad. Yes. So let's do that. Let's just leave it like so. So in order for this to work, all it does is has this script component called on-screen button. So this will allow it to be interactive and so that you can click on it or tap on it or with touch input. And the control path is basically a binding. Here is where we can say when this on-screen button is pressed or clicked, is going to behave such as a right trigger on a gamepad. And that is how we can simulate a gamepad using on-screen controls. So if I enter play mode now and I click on this button, so I'm not using the keyboard at all. My other hand is here. So the controllers are here and just not touching them. So again, I can press on the right trigger on the actual gamepad, or I can press on this on-screen button right here. Let me zoom in. And when I click on it, you can see that it moves the character forward. And the same thing happens with the left trigger. So I can drive forward by clicking on that on-screen control, and also steer. So in order to make it easier, I'm going to use the throttle on the gamepad, and I'm going to use the on-screen control to steer. You can see how it's changing the wheels there. The UI here on the lower right-hand side corner is also responding because it's bound to a gamepad, and these on-screen touch controls are simulating behaving as a gamepad. So that's why the binding, even though the binding is set to the gamepad, this works. And that is on-screen controls. Alongside the input system in the package manager, you can find a list of samples, showing you many ways you can leverage the input system, from creating your own binding composite to on-screen controls. Let's have a look at this. So if I zoom in, you can see a bit of this list right here. So we have things such as custom binding composite, custom device. So this is in the case that you have a new piece of hardware and you want to simulate it. You can make the definition, as well as create a real definition for a real piece of hardware that is not supported in Unity yet. Custom device usages, gamepad mouse cursor. This is so you can simulate a mouse pointer using a gamepad with analog stick, for example. In-game hints, input device tester. The input system is very easy to extend and simulate input. That's why we have things such as input recorder. This is also very helpful for testing. On-screen controls, as we've seen before, and rebinding UI, also we demoed that just now. And also there is the ability to show single multiplayer. Simple multiplayer is how to use different input systems, input devices in your project to tie them to different players. So you can have multiple players playing co-op. What's the difference between UI and game input and how to toggle between them? This is very similar to what we did just now, toggling from in-game to pause. And finally, there's also a sample project for visualizers. There is a more complex project available for download, which demonstrates a number of scenarios. So input action control scheme for basic player controls, directional axis for movement, button press for attack, setting up a keyboard and generic gamepad bindings to the control scheme, instantiating multiple player controllers for a local multiplayer setup, UI input, virtual joystick and virtual button for touchscreen controls, runtime switching between player control and menu control action maps, UI for rebinding action controls to new buttons and joysticks, and callbacks to detect disconnecting and reconnecting devices at runtime. Here is where you can find some of the resources and sample projects that we were talking about just now. The Warriors example right there, as well as some general information about the input system. And I would recommend also these videos from Unite, where the developers who worked on the implementation of the input system describe some of the features in more detail. And as well as the workflow and tips, which walk you through some of the workflows that the Warrior example project is based on. I hope you all learned something useful during this webinar. Thank you so much for tuning in, and I hope you have a great time exploring the input system and building UI for your games. If you have any questions, the team and I will be more than happy to help them answer. Thank you so much, and now we're open for questions. Okay, so We are at the end of the presentation, and I'm going to be looking at any questions to answer live right now. So I'm looking at the questions box, and I see one question coming in. It says, how can we create virtual on-screen steering? And how can we configure phone gyroscope with Unity? Okay, so two questions. We can do two different types of things. So the first thing that comes to mind when you say virtual on-screen steering. So you could use one of the given analog stick touch-based or screen-based analog stick controls, like the one that we showed just now, that are part of the samples. Or you can create your own code where you click on a virtual wheel on the screen, and then you can move it around by swinging in an arch form. But you would have to code that. And then of the resulting angle, you can feed that back into the input system, the same way that the touch control works. You can just explore how that is doing that. But basically, the input system is very open. So if you look at how those touch control systems work, basically they are passing as input from the gamepad. They are like creating like pretending to be a gamepad. So basically you can pretend to be any of the other devices and feed in events into the input system, and any bindings that are expecting controls to be activated, they don't really know if it's coming from the actual hardware or if it's some code that is actually sending an event that is simulated from another source. And how can we configure phone gyroscope with Unity? I would have to investigate a bit more on that, but I understand the gyroscope is considered one of the devices. It's an abstract device, similar to what we saw just now in the example, like the gamepads and the keyboard and mice. The gyroscope is an abstract device that you can bring up in the input debug window and see all the values. But usually what you're doing with the gyroscope is reading it. It's a read-only sensor when it's available, and you can see all the information. And from there on, I guess you can use the data as it comes in from the sensor directly and interpret it any way you want. But I'm sure you could also try to use interactions, maybe create interactions exclusives for gyroscope that will detect gestures. I think that would be a good idea. But most of the times, many developers that focus on gameplay try to implement their own version of that, how to parse and process the input themselves as opposed to using interactions. Unless it's an interaction that is very useful and common use. For example, like the multi-tap, that is a way to encapsulate and allow any arbitrary number of taps to be included. So you can define 2 taps, for example, and a multi-tap interaction to support a similar behavior to a double click that you are used to. But imagine that instead of 2, you set the number to 10. And then that becomes very much like in those games where you have to repeatedly tap a controller 10 times maybe to achieve, for example, to open a chest. So that's some of the things that you can do with gyroscope and virtual on-screen. Then we have another question. It says, when approaching rebinding UI, the Unity samples and all the tutorials use the PlayerInput component, but I generated C# class for my project and I use this approach. So how can we rebind input this way? So actually, all these different approaches that we've seen, they're all based on the same thing. Actually, the input assets, the window that I show you how to edit and create the bindings is doing nothing but underneath, behind the scenes is creating a definition of a structure and storing it as a JSON format. Even when you create that C# class out of that input assets, the C# class includes a copy of this JSON structure. And if you study the documentation, you will see that everything that we do in the inspectors can be done using code as well. We can create an action map, instantiate an action map using code. We can add actions to the action maps that we created using code. And we can add the bindings that we imagine that we just what we saw just now, the drop down where we select the things from a list. Actually, those are just a simple way to come to find the specific identifiers. but there's nothing that prevents you from doing that in code. So my recommendation is, as I was working on this sample project for this webinar, the C# approach is a very good approach to get something done quickly, because you can just define your bindings visually in the editor window and generate a C# class that gives you all the access or all the properties through code already provided. But in case that you want to extend it, ideally you will always have to read them from a player input. In the case in the future that you're going to have situations like we have just now, for example, the post menu, it makes total sense, because then there's an easy API on the player input where you say, if we have different input maps, for example, driving and pause, I can say, okay, focus on the input map, for the navigating the menus, and that will automatically disable all the controls on the other input maps. But if you don't want to use player input, you can think of doing that yourself as well. If you're using C#, it's a bit more trouble because you have to keep track of that yourself. But you would notice that in the simple example of using C# based input bindings, there is a call to the enable function. That is basically enabling the input maps. So if you have multiple input maps, you can call enable and disable manually yourself. So a player input is simply a way to standardize, but you can see how it doesn't really, it's not using anything internal. It's simply like a wrapper or like a guide on how to use the binding system. Okay, next is, which is a better action maps or C++? This one, I don't quite understand what it means. And the gyroscope questions, I don't know. I think we are out of questions in the box, unless anyone else has anything to say. We have
Just to
Sean.
jump in right now for a bit, Hector. We just shared the survey link in the chat box, so please fill it in if you like a chance to win a Unity sweat pack. We actually do review all of your feedback and we use it to improve future sessions, so appreciate any feedback that comes in. In the meantime, Hector, would you like to share today's best question?
Yeah. Okay, so we were having a discussion internally about the questions as they were coming in, and one that I found very interesting was early on, the question by Joe Adams. It says, is it possible through the input system to bind to a device like a microphone or a custom function as an option for driving input when the voice command is spoken? And yeah, the answer is yes. You could potentially, very similar to the on-screen controls that we saw last in the presentation, those are actually pieces of UI that respond to being dragged around the screen, and then they mimic, they simulate being like a gamepad control. So there's nothing that prevents you from having other systems, for example, a microphone where you can read the values of the levels of the audio signal and use those values and route them through the input system. They can pass as another device, like a gamepad trigger, for example, or you can create your own custom device called microphone, which has all these bindings built in. This ability to read the audio from a real microphone built into it, and it will route it and expose it so that it's easier for other developers to just pick up this microphone device definition and bring them into their project and start using it.
Awesome. Congrats, Joe. So I've dropped you a message and I noted down your email address. So we will be contacting you after today's session. And also we'll be conducting the draw for the lucky winner for today's session after this webinar is ended. So if there are no more questions coming in, I think we can close off for today. Thanks a lot for joining us for today's session. And yeah.
Thank
Hector, you
you,
have any
Sarah.
closing
Thank you,
words?
everyone. Nothing else from me. Thank you for tuning in.
Thank you.